Hey guys, it's Miss Rooker. Go ahead and pause the video really quick and do the review problems and then unpause and I'll have the answers for you. Here are the answers to 1 and 2. 1 was pretty straightforward. You just solve by, whoops, I forgot. I said it was straightforward, but I had forgotten the plus or minus. So you solve by square rooting both sides, but don't forget, like I did the first time, that you need to put a plus or minus anytime you solve by square rooting. And then you have to take an I out since it's the square root of a negative. And then the second one is a little more complicated. You have to distribute, then rationalize the denominator by multiplying by the conjugate. This is the conjugate. And then you got to do a lot of simplifying. So your answer should end up being, it looks like D is the same as this answer that I got here. They just split it into 2 separate fractions instead of 1. All right, so today we're going to be doing the rational zero theorem, which says if a polynomial function has integer coefficients, integer means whole number coefficients, then every rational zero of the function can be or has the following form, and that is the form P over Q, where P is the factors of the constant term over Q, which is the factors of the leading coefficient. We'll call that LC, leading coefficient. All right, so basically what we're doing here is we are finding a list of possible rational solutions. For our purposes, rational just means nice solutions. They can be fractions or they can be whole numbers, but they're not going to be any square roots, any crazy radicals or imaginary numbers or anything like that. So to find these, we are going to find a list of the factors of the constant term. So the constant term is always the number on the end. So the factors of 12 are going to be 1 and 12. I always start with the outside numbers and then work my way in. 2 times 6, 3 times 4, and then my next one would be 4, which I already have, which means that's my completed list of all my factors of 12. And then I also need a list of the factors of the leading coefficient. Well, my leading coefficient is 1. My only factor for 1 is 1. Really important, though, you need to not forget that all of the opposites of these are also factors of 12. So I'm going to make sure to put a plus or minus in front of each one of these, because negative 3 is also a factor of 12, and negative 4, and negative 6. Should have left more room on that, sorry. All right, so to find the possible rational zeros, I do all of the factors of the constant over all the factors of the leading coefficient. So I'm going to do 1 over 1, so plus or minus 1 over 1. And then I'm going to do 2 over 1, plus or minus 2 over 1. Then I'm going to do 3 over 1, so plus or minus 3 over 1, plus or minus 4 over 1. Then I'll do 6, plus or minus 6 over 1. And then lastly, plus or minus 12 over 1. So these are all the possible rational zeros, and then we're going to simplify all those fractions. This just simplifies to plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Which means to me that all of these 1, 2, 3, 4, 5, 6 numbers, well, I guess 12 numbers, because there's positive and negative, could be a solution to this system. Okay. Doesn't mean they all are. Really, we can't have any more than 3 solutions because the degree is 3. But some of these will probably be solutions to that problem. All right, let's try that on the next one. Let's try sorry, I keep stumbling over my words. We're going to do a list of all the factors of the constant term. So this is the constant term. Plus or minus 1 goes into everything, and 10. 1 times 10 is 10. Then I'll do plus or minus 2 and plus or minus 5. 3 doesn't go into 10. 4 doesn't go into 10. 5 does go into 10, but I already wrote 5. So I'm done. That's my completed list. Then I do the factors of the leading coefficient. So this here, 4, is the leading coefficient. So plus or minus 1, plus or minus 4, plus or minus 2 times 2. And then 3 doesn't go in, and no others go in besides 1, 2, and 4. All right, now we need to find the possible rational zeros. I need to do 1 over all 3 of these. So this is going to be plus or minus 1 over 1, plus or minus 1 over 2, and plus or minus 1 over 4. Then I need to do that same thing, but instead of doing 1 over everything, I'm doing 2 over everything. So this is going to be 2 over 1, then 2 over 2, then 2 over 4. Now I need to do 5 over everything. So I'm going to do 5 over 1, then 5 over 2, then 5 over 4. And lastly, I'll do 10 over all 3 of these. So plus or minus 10 over 1, plus or minus 10 over 2, and plus or minus 10 over 4. Now, this is why it's necessary to have a simplified list down here, because obviously what we have right here is not very nice and simplified. So the first one, 1 over 1, just simplifies to 1. Then 1/2, I can just leave as plus or minus 1/2. Then plus or minus 1/4. Okay. Now, next in our list, we have plus or minus 2 over 1, which I just reduced to plus or minus 2. All right, then next on the list, we have plus or minus 2 over 2. 2 over 2 is just 1, just reduces to 1, which we already have in our list. So I don't need to repeat that one. So I'm going to move on to 2 over 4. Well, 2 over 4 reduces to 1/2, which I already have. So I don't need to repeat that one either. So I'll move on to plus or minus 5 over 1, which just reduces to plus or minus 5. Then 5 over 2. And then next we have 5 over 4. And then we have 10 over 1, which reduces to 10. Sorry, I forgot my plus or minus. All right, then 10 over 2. 10 over 2 reduces to 5. 10 divided by 2 is 5, which we already have, so I don't need to repeat that one. And then lastly, 10 over 4 reduces to 5 over 2, which again, we already have, so I don't need to repeat it. So this is my final list of possible rational zeros. So whenever you see it say possible rational zeros or possible rational roots, you're going to use your P over Q's. All right, now we're going to use this information to help us find the actual real solutions to a function. So we're going to follow these steps. We're going to list all the possible roots using P over Q. Then we're going to test them using synthetic division to see which ones give us a remainder of 0. If they don't give us a remainder of 0, then that means they are not zeros. They're not solutions. And then we'll have to try more until we find one that actually does give us a remainder of 0. And then we will factor the remaining polynomial and solve for the remaining zeros. All right, so first thing, we need to find the possible rational zeros. We'll do all the factors of 20. So I'm just going to save the plus or minuses for later, and I'll do the factors of 20. So 1 and 20, 2 and 10, 3 doesn't go in, 4 goes in, it's 4 times 5, And then the next factor would be 5, and I already have that. And then I need to do that over all the factors of the leading coefficient, which is 1. So basically all of these go over 1, which if I put something over 1, I just get itself. So I'm not even going to bother doing that. But one thing I do need to include is that all of these will have a plus or minus in front of them. All of them can be positive or negative. So that is 1, 2, 3, 4, 5, 6 times 2 is 12 possible rational zeros, because each of those could be positive or negative. Now, I'm going to pick one that looks easy, and I'm going to use synthetic division to see if it is a solution. So, synthetic division, I line up all the coefficients, 1, negative 8, 11, and 20. And then I'm just going to try one. So I'm just going to try this first one. It looks easy to me. It's easy math, so I'm going to try and cross my fingers and hope that it is a solution. So bring the 1 down. 1 times 1 is 1. 1 minus 8 is negative 7. Negative 7 times 1 is negative 7. Plus 11 is negative 4. Oops, positive 4, sorry. Times 1 is 4. Add straight down, I get 24, which is not what I want. I want a remainder of 0, which tells me 1 is not one of my solutions. So now I'm going to try again. This time I'm going to try a negative 1. 1 times negative 1 is negative 1. Negative 8 plus negative 1 is negative 9. Times negative 1 is positive 9. Add straight down, I get 20. Multiply by negative 1, and I get negative 20. Add straight down, I get 0. That's awesome. That means to me that negative 1 is one of my solutions. So one of my solutions is negative 1. Then I'm going to write this as a polynomial. This is going to be 1x squared minus 9x plus 20. And now that I have something that's more simplified, I can factor this to find the other two solutions. I do the big X, what multiplies to 20 but adds to negative 9. That's going to be negative 5 and negative 4. So this will factor, since this is an easy trinomial, to just x minus 5 times x minus 4. And then I solve. I set each factor equal to 0. I end up getting that x equals 5 and 4 and the negative 1 that I already had. And you might notice 5 and 4 were also on my list of possible solutions, which they should be since they ended up being solutions. All right, so that is it for that one. Now we'll move on to the next one. We're going to find all of the possible rational roots first. We're going to do the factors of 24. So 1 and 24, leaving a big gap because I think there are a lot of them. 2 and 12, 3 and 8, 4 and 6. 5 doesn't go in. 6 goes in, but I already have that one, so that means I'm done. And then I'm going to put those over all the factors of 1. Well, the only factors of 1 are 1 and negative 1, so these would all just go over 1, which isn't necessary to write. So this is my completed list of possible rational roots, as long as I include a plus or minus in front on all of them. Remember, all of these are positive or negative. All right, now I'm going to try synthetic division to find out which one of these actually do work as solutions. But be really careful. We need to be in order by degree without skipping any. And, oops, I meant to erase that. And it looks like we're skipping or we're missing a 0 degree. Sorry, not a 0 degree, a third degree. So my leading coefficients will be 1, 0, negative 15, negative 10, and 24. And then again, I like to try 1 first. That one seems easy. 1 comes down, 1 times 1 is 1. Add, we get 1. 1 times 1 is 1. Add, I get negative 14. Negative 14 times 1 is negative 14. Add straight down, I get negative 24. Multiply, I get negative 24. Wow, that was really lucky. What that means to me is 1 is a solution. I want to write that so that I don't forget that that is one of the solutions. All right, now I could try and write this as a polynomial, but this would be, I started with something that was x to the fourth, I divided it by, I divided one factor out of it, so now it's going to be x to the third. Which still isn't something I can factor. It's still third degree. So I need to divide out another solution from this so that I can simplify it even more into something that I could then factor. All right, so what I should do is pick another one of these and use synthetic division on my new, I don't need to include the remainder anymore, that can go away. On my new polynomial, I'm going to use synthetic division with one of the other ones. I don't want to take a ton of time, though, and try every single one of these because that can take a really long time. So I want to use a resource that I have, which is my graphing calculator. Sorry. All right, so I was trying to use the graphing calculator on my computer to show you, and it's really glitchy and it's not really working. So instead, I typed this into my graphing calculator. That's not on my computer, my handheld graphing calculator, to get the graph. And just be really careful when you're typing in. Ask your teacher for help if you need help typing into your graphing calculator. But when I typed it in, I got a kind of funky looking graph that looks something like, it's a little hard to see. Some of it was really off the graph. It just looked almost like a bunch of vertical lines. It looked like really steep through here, and then it kind of disappeared outside of the graph to where I could see it, and then it came back up through here, and then it came back down somewhere around here, and then back up somewhere out here. So really what's happening is it's kind of, it should look like this. We're just not really seeing where it curves back around. But you can see here that we ended up with four real solutions here, which hopefully makes sense since this was fourth degree. Okay, so we have 4 solutions, and we can kind of look at the graph and see where we think those solutions look like they are. And when I use my little cursor on my graphing calculator, I can see it looks like this is around -3. This one looks like it's around -2. This one looks like about 1, and this one, let me scroll over, I think it's around 4, but I want to double check it. Oops. Keep scrolling. Yeah, it looks like about 4. We already said that 1 was a solution, so we already got that solution. Now we're thinking 4, -2, and -3 are probably also solutions. So I'm just going to do synthetic division to confirm that those are also solutions. So I'm going to do 4 next. It really doesn't matter which one you do, but I'm choosing to do 4. 1 times 4 is 4. Add, we get 5. 4 times 5 is 20. Subtract, and I get 6. 6 times 4 is 24. Add straight down, I get 0, which does confirm to me that 4 is a solution. All right, and then I ran out of time on my video, so I had to kind of cram this in here. Then the next thing I would do is rewrite this as a polynomial, which I did right here, and then I factored that polynomial to confirm that these were solutions. I also technically could have just done synthetic division a few more times with -3 and -2 to also confirm that those are solutions. All right, but that is all I've got for you guys today. Have a good one.